That was laid back, walking in the sunshine. It's good. This Danish guy from the 70s. He has a very famous song called White Horse about heroin, I think. It's very famous from the 80s. Anyway, hello, recording. Okay, let me get on Zoom. There was a guy on Sproul who had a sign that said, "Show me your TikTok history." Or not your ChatGPT history for money. Oh, we got music again. Shh. It's a good song. Okay. All right, here we go. Okay. It's a laid-back day, I suppose, because we're 40 seconds after the break. Hi, Zoom. Okay. All right. Let me share my screen. We're going to build some more stuff today. That's going to be the plan.
Recording in progress.
Thank you, Perrin. All right. So this is where we left off. We were trying to build this hexagonal world. The goal was to build a world generator where we can make worlds of various hexagon sizes. And we had gotten as far as well, we'd made a hexagon class that had some different instance variables that were the x and the y of the top left corner, the size, the type of hexagon, and we didn't actually do this. That's what we were getting to. And we also wrote this draw horizontal line method. So this is the code we basically wrote so far that's most notable, and this is the main method, where there's this code up top which was initializing graphics, and this is what you'll be doing on Project 5. So you set up your graphics renderer. You make a world that has nothing in it, so it's a 40 by 40 nothing. Then we created a hexagon, and then we had this funny thing where we made a line of locked doors, and why did we do that again? Anybody remember? What was the point of doing that? Yeah? Yeah, we wanted to make sure that we could eventually draw the hexagon by drawing this line. So we were double checking that this method actually exists, or sorry, that it actually works, okay? So that's where we left off. And we don't need that to be animated yet again. So we're going to keep going by getting single hexagons working. So I'm just going to write some code. And along the way, I'm just going to show my thought process. And you can interrupt me. We can make things better or worse later. But that's where we left off. We made this right here. Okay. So we want to draw a hexagon. So I'm actually going to go back to the slides and think about what a hexagon is. What do we do next? We need to figure out how to draw a hexagon. So if we were drawing lines, like someone in English describe roughly how you might draw some hexagon. What is it? Say again? It's got 6 sides, yeah, but we're not drawing the sides and then filling in. I want to use my draw horizontal line method. So I'm decomposing this thing. I mean, what do you draw first? If we're drawing this grass. The top. And how big is that thing? 4, and then it's 6, then 8, 10, and then 10, 8, 4, 6. Okay, so let's try and do that. So we're going to, it was too big. Okay, other way around. All right, so let's go back to this lecture. We had done draw horizontal line, and for now, I guess I'm going to try and figure out, I want to draw the whole hexagon. So where am I going to put this code, I guess is my question for you. Like, where do you want the draw function to be? Is it part of the hexagon class? Do you want it to be part of the lec31 class? It's your choice. And, we're just being tactical here. We're not really thinking ahead too much. What do you want? Hexagon class? All right, let's go to the hexagon class. I'll add a method, and we'll call it draw hexagon, or I don't know, add hexagon. That's what I called it before on the slides. Okay. I guess it'll be void. Could be. Maybe, maybe not. And what does it do? It's going to be calling draw horizontal line. Let me copy real quick what one such call looks like. I was going to have this here as a reference for us. This is roughly what one of the calls might look like. So what do I need to do? Do I need arguments to this thing? What do you think? Needs the world. Okay, so we'll give it the world. And I'm going to do void. So I'm going to change it in place. It would also be valid to say, I'm going to make a new world that's a copy that alters, like I don't modify the original world and I return a new changed world. Or I could do it in place. What's one reason this might be better? Give me an argument for why it might be nice if it's make a new world with the hexagon added. It's a pure function, right? Maybe it's easier to reason about. What's better about this, maybe? Yeah, less memory, sure. Yeah, more in line with graphics being state machines. It's like, it just feels more natural to call rather than to take a world and make a new one. So it's a debate. You can make it a pure function. So could be pure, could be not. And by pure, I mean it has no side effects and returns a copy. We picked impure because we are impure people, I guess. Okay, so here we go. Let's first draw just the top half. And why am I doing that? I don't know, it just seems natural to me because it feels like sort of two tasks, top half then bottom half. So I'm going to iterate how many times? 4, or more generally, we have the size variable, so I'm going to say size. So I less than size, and I'm actually going to call this thing row num because I want to remind myself it's a row number. And then I'll increment. Okay, row num plus equals 1. All right, there we go. So now I'm going to start drawing some horizontal lines. So where do I put my first one? I'm going to put it in the world. It's going to be at top left x, top left y, and it's going to be some length, which I'll just say size. I think that seems right because it's supposed to be 4. And then I'm going to give it the biome. That's what the variable was called. So here we get a complaint because we need to import that method. And let's see. So that will give us just one of the lines. It's not going to use the row num yet. I'm going to run it real quick just to see what happens. Nothing. Is it top where? Oh, y. Yeah, thank you. That would have been tricky to diagnose, perhaps. Okay, so let's go back in here. And let's go to lect 31 and actually just do like a little dummy call. So let's do demo hexagon dot add hexagon world. And let's get rid of this thing. So if we run this, we should get part of the hexagon. Yeah, there it is, at the bottom. Okay, so that's the hexagon. It's being born, right? That's what we got so far. But we want to give it life. Okay, yes. I'm a little surprised it's so down there at the bottom, but maybe that's just where we put it. Let's see. We said 10, 10. Okay. Well, we'll keep playing around with it because, we're doing everything interactively. Okay. Let's keep drawing more. So I didn't actually use the row num. What's kind of the pattern? Well, I know that for a size 4, and this is how I like to think about things, maybe on paper, but with you, I'm going to do it in comments. So I'll say the first line is at top left x, top left y, and length size. Okay. The second line is at where? So if we look at the picture. Yeah, x minus 1. And top left, what do you think this one is? Plus 1. It depends on how y is defined, right? So the spec in Project 5, I'm pretty sure, but I actually don't totally remember, I'll admit, is that it's actually lower, that this is 0, 0, and you go up. But it just depends on the semantics of how the graphics library is designed. Let's try this. And then the length will be size plus 2, because they're supposed to go from 4 to 6. All right? And then we can see the pattern. The next line is going to be at minus 2, minus 2, I think. But that's fine. This is the experimental programming that you should try do. Don't overthink it necessarily. It's nice. You feel like cool if you can predict it in advance, but maybe that's fine that you don't. Okay, so what I'm going to do here is I'm actually going to call, so it's top left minus row num, because row num's first 0. The next time it'll be 1. Okay, this one's going to be minus 1. And then he will do plus 2 times row num. Okay, and I think this, say again? Row num, yes, thank you. But my brain substituted in 1 for row num. Weird. Okay, all right, there's nothing there. That's strange. Okay, so why is that happening? We going off the thing? Let's scoot it up a little. I'm a little surprised that I'm not seeing anything. Top left, size plus row num biome. Okay. It was there before. We saw the basic one. And this is just life. So let's do, I don't know, 2020 or 1020. Okay, we see nothing. Okay, that's interesting. How would I figure this one out? Lect 31. What was the call we had before? This is quite surprising to me. We had that. So this one showed something. There it is, at the bottom. Not where I expected it to be. And then once we subtract off the row num, anybody spot it? Maybe not. Let's check that out. Draw a horizontal line. World x, y, size t. X, y, size t. Interesting. Yeah, good idea. Let's do +5. Oopsie. This is a great debugging strategy. Okay, I think it scooted over to the right. Okay, what if we do this, +5? Okay, it moved up. That's a good sign. Yeah. Okay, so this is kind of interesting. Ooh, right. Things are behaving weirdly. Check this out up here. Anybody spot something weird here? This is highlighted. Top left, this dot top left y equals top left y. This is highlighted because it says it's assigned to itself, because I had a typo last time. That would be a real pain to figure out. Okay, so the way I figured that out was by playing around with these parameters, saying this is not behaving how I expect exactly. Okay, so let's do top left y. Sabotaged ourselves before we even got started. Okay, so it was starting at y0. All right. And I guess it was going off the world. Okay, let's try again. Okay, and again, this is exactly how I would approach this if I were working on this myself in 61B as a student, right? I'd play around interactively. I'm not gonna try and plan too far ahead, but I'm not gonna not plan ahead. You know, it's kind of a medium amount. Looks good? Yeah.
Okay, so I'm kind of losing out the context of the A stuff in the past lecture on the hexagon implementation.
Yeah. Sure. So in terms of like what we're even trying to do in the first place? Yeah, so the goal is we want to build this world. So what does this world consist of? It consists of, this is inspired by this board game, Catan. And in it, there's a world that consists of a bunch of different like hexagonal tiles, like a little world here, where this is a mountain region, and tree region. And the world should be 3 hexagons, then 4 hexagons, then 5, then 4, then 3 always. Make sense? So that's the goal. That's what we're trying to do. Good? Okay, great. All right, now we need the bottom half of the hexagon. So I'm going to delete all these comments we used as we were experimenting. Before I do that, I'm just going to double check that if I pick a different size, it looks okay. Because I don't want like an error. Say I made an error that's like somehow size dependent. Let's try 3. I want to catch it before I make the mirror image. Okay, that actually looks good. 3, 5, 7. So that's a good sign. Let's do like 6. Okay, yeah, that looks plausible. Okay. If I were more careful, maybe I'd have counted, but I didn't. Let's do the bottom half. Okay. A lot of ways you could try to do it, but I'm going to do it really lazily, and I'm just going to say, first call, same thing I did before. First call is draw a horizontal line, and it's going to be, I don't know, x plus, or it's going to be whatever we ended up at. So if this was x, where's it going to end up at? X, or x minus size, right? Starts at x minus size, roughly. Maybe it's off by 1. We'll fix it. And then it's going to be y minus size. And it's going to be what width? Size? Say again? Let's try 2 size. Sure. Okay. That sounds like a reasonable hypothesis. But we'll check it. And then the second call, and you know, again, we're kind of spitballing a little, and this is totally okay, right? So we have x minus size, y minus size, 2 times size. The next one's going to be x minus size plus 1, y minus size plus 1, and this one, if we're following this pattern, will be 2 plus size minus 2, right? It's slightly off, and let's imagine, yeah, you're right. So if you're paying real close attention, you can spot there's a small bug, but maybe you don't. I'm going to do row num equals 0 again. You could try and do this and say, oh, maybe it's greater than 0 and I'll subtract. But now you're kind of going into double negative territory. I think you're trying to be too clever if you do this. You can. Not how I would do it. Because that doesn't match this little example I did up top. Okay? So where do I start? I'm going to do the following. I'm going to make a helper variable because I'm going to say, we'll call this like, I don't know, first x equals x minus size. First y equals y minus size. And first length equals 2 times size. Okay. The reason I'm doing this is there's like a starting point. Like the pattern is clear to me that it's definitely +1, +1, -2. Like I know that as I work my way through, I definitely want to go over and down, over and down, over and down, and always subtracting 2. The part that I'm maybe a little cautious about and that you've identified is maybe where I start with each one. So that's just what I do because it's like a hook. It's like that's where I start, and I'm going to make a certain pattern from there. It also means the code is a little more narrative. And let me show you the alternative in a sec. So I'm going to say first row plus row num, first y plus row num, and first size -2 times row num. And there's some first length. OK. The alternative to doing that would be, well, why is this thing red? Is it because it's, oh, top left X. Thank you. OK. So I could have not had these variables and had the code look like this. But this is harder for me to think about because there's two things happening at once. I'm like, where did I start? OK, then I went over here. Oh, now how am I changing it again? So I like to have it like this, where it's, I put aside like the, I don't know, first X maybe is a weird name, but it works for me. I'm happy with this because I've broken it into 2 steps. Does this use slightly more memory? Yes. Do we care in the year 2025? Not whatsoever. In fact, it might not use more memory, depending on how optimizations run under the hood. So we try running it. And we get not quite the right thing. OK, so why did that happen? Well, there's a couple problems. I'm only getting one line here, right? Like I'm expecting more than one thing, and it's like off in the wrong position. It's not the right size. That's interesting. Let's try and diagnose this in a somewhat funny way. I'm going to ignore whatever the biome is and put mountain, because I want to know which part of it is wrong. Okay, that's what jumps to my mind immediately once I import this thing. Like to see if there's like some overlap. Okay, oh yeah, right. This is like, if I left it as tree, it looked like I had only one line wrong. But actually there's many wrong things here, right? Like I actually overwrote a lot. So what I wanted to do is make it clear what this code is doing, right? I gave it the stink of mountain, right? Okay? So what did we do wrong? Like we started in totally the wrong place, which was not obvious until I changed this to mountain. By the way, I've not rehearsed this. It's just me going off the dome, and I hope it's making sense. Okay, any questions about where we are so far? I hope this is useful. Okay, so what do we do wrong? I mean, it's clear that first X is wrong. So what happened here? First X. Okay, top left X minus size. That's not where I'm expecting it to be. Oh, that's because that's there. Okay, this is where I started. And then I'm going up, I think. Minus row num. Okay, yeah. Okay. Yes, okay. Cool. All right, there. Getting better. So we turned it the right way, but now it's still slightly in the wrong place and slightly the wrong width. So what do we need to do? We'll scoot first X over by 1. Okay? Is that a little dirty that I did that experimentally? Sure, but do I care? No. I mean, again, you can rationally design in advance, and that's perfectly fine. But if you're a little lazy, it's okay that you kind of came to it by a little bit of experimentation in this case, right? What's wrong here? Size is starting off slightly wrong. What do we need? 2 more. Okay, right. Okay. And so this is the part where I'm going to fix it. And if you like, sometimes you can say, well, that seems like a little weird. Like, why is that? And this is when you sit down and maybe with a piece of paper, you like start drawing like, okay, if there's 3 of them, you know, what's the pattern, and so forth. Then you can figure it out, and then you can be satisfied and like grok deeply why it is 2 times size plus 2, or maybe you don't care. But I'm not going to go into that. That's the thing that you do maybe retrospectively. It's kind of like in a mathematical proof, right, where you're trying to prove something in a class like CS70 or Math 1A or whatever, and you like kind of get the pattern, and then you, after you observe the pattern, then you can try and abstract and figure out why it was the case. But I'm not going to do that here. Okay. We can draw hexagons. Marvelous. Let's switch back biome. Okay. Yes. So there we go. So we've drawn a hexagon. All right. So we made hexagons. What do we do next? We need more hexagons. Okay, so let's try and think about how we do that. So I'm going to go back into this Lec 31. And again, I'm just going to do things quick and dirty at first. I am going to imagine that we want to draw more hexagons. We could do something like, I don't know, let's try doing demo hexagon 2 and add another one. I don't know that we'll learn a lot doing this, but I'll do it real quick anyway. Let's see what happens if we do this. We should get 2 hexagons. Okay, oh wow, I nailed just guessing. Nice. I think. Maybe there's one overlap by 1. Yeah, but close. So we could do something like that, but I don't want to do that. I want to build something that's more useful. So anybody want to suggest something, and I might ignore you? Well, yeah. So I guess like there's different layouts you could do. I guess you could do like you're playing the actual board game and go like counterclockwise around, but that's gonna be painful. Yeah. Yeah. Yeah.
I'm also like noticing that with the hexagon like adjacent to itself,
Yeah.
the top or the bottom of the top right hexagon starts at the, like if you go to the middle one
Yeah.
on the left,
Yeah. Go from middle to top left.
all the way to the left,
All the way to the left. Yeah. Oh, they line up. This, this, this. Yeah.
like the top of the one to the top right of it,
Mm-hmm.
the bottom of it lines up with the middle, the top half.
Yeah, so there's different, maybe the short version of that, there's different patterns you could do, like observing that there's different ways to line out. So there's many different ways you could try and lay this thing out. One natural one is like draw the top one, then draw these 2, then draw these 3, then these 2. But that's more complicated to me than the way I want to do it, which I've already kind of given a prelude to. I don't know. Give me a suggestion though how you want to draw it. Yeah.
You start on the leftmost and then you just go down 3.
Yeah, I think 3, 4, 5, 4, 3 is the easiest way. But you could do something else. I don't think that top, next 2, next 3, next 2, next 3 is as nice. And you could do other things though. Whatever you want's fine. So I'm going to do that. I'm going to try and draw a column of hexagons. That's what I want to do. So I'm going to write a function. And I'm going to put it here. Why? I don't know. Just where I decided to put it. Draw hex column. Okay, so what does it do? You give me a world. You give me an x and a y. You give me a size. You give me a num hexagons. And you give me a tile. Okay, fine. Yeah, it can be a hard-coded tile for now. That's fine. And now what I want to do is this function is supposed to draw a column of hexagons of the appropriate size, starting from x, y as the top left of the first such hexagon. Okay, so I'm basically going to, like if I'm drawing some hexagons, it's going to be like H, H. If I'm drawing 3 of them, it'll be, this is the starting hexagon, and then I'm going to draw the next 2 below it. That's just how I've decided to write it. But again, any primitive is fine. There might be a better choice, but this is what I've chosen to do. I'm going to delete this stuff. And for now, I guess I'm just going to draw 1. And we're going to put in x. Actually, I'm going to save this real quick. Okay, x. We'll do y. We'll do size. We'll do tile set tree. And we will just make a dummy call real quick. Make sure that we didn't mess something basic up. Okay, so draw hex, because I want to do this experimental approach. So I'm just going to call draw hexagon 1024 tile set tree. But I have one extra thing, which is how many to draw. So this wants to draw 3 hexagons starting at position, world. 10, 20, 10, 4, 3 tile set tree. This is a lot of parameters. Maybe a little dirty to have this many parameters. 6 parameters is maybe a lot in a function, but it's like sensible enough. Okay, so I tried calling this function. I got nothing, which isn't what I wanted. Demo hexagon. Why didn't it work? Well, I have add hexagon here. I didn't want that to happen. This is a boring bug to do live. Okay, well, I could. Yeah, fine. Okay, demo hexagon. It actually got called. Where's the thing? Debugger. Oh, it's down there. Okay, we made a hexagon. look okay? Yeah. We added it to the world. Then what? Where are we? The application is running. Oh. Is it stuck? Huh? Why are we here? Okay, let's look.
The window is just somewhere, right? I think the window's just there. This is like an event room.
Yeah. Oh, I see. Let's try running it one more time. Oh, we ran into a bug. Okay, we crashed. All right. No such method.
Why is there no pile there?
That's weird. This is a stumper. Like 31. No such method? Oh, dear. I think it's got one. Oh, did we delete it? Oh, I deleted the method. Oh, ha. And then it's okay. Well, then. Let's bring it back. That's a weird bug. Okay, I didn't plan that one. Didn't plan any of them. Okay, let's go back and grab it. Actually, no. Let's just go to the terminal. Grab it the old-fashioned way. Okay. X, lecture code, fall 25, lect 28. Okay. Let's get our precious function, because I fought hard for that function. There you go. Okay, our method's back. Whew! All right. There we go. Hooray! All right. Oh. That wasn't what I expected. I just created myself. I meant to push that stop button. Yeah. All right. So, where were we? Okay, we wanted to make a hex column. All right, so let's do this in a loop. For int I equals 0, I is less than num hexagons, I plus equals 1, and we'll create a demo hex. Oh, God, it's like, call it temp hex. Okay. All right, so we're going to make a bunch of hexagons, and each hexagon should be, they're all going to have the same x, right? But they need different y's. So how do we change this? Someone suggest a function. 2 times size times I? Yeah, that might be right. Let's run it. Yeah, looks good. Okay, and we just, it's a gut feeling. Sometimes it's a gut feeling.
Are we going to the top or are we going to the bottom?
Good question. Okay, well there we ran off the bottom of the world. Let's see. Let's make the world a little bigger. On this projector, for some reason, I have a little less. Ooh, okay, hold on. Let's fix this. I hate this. Private static int width equals 50. Private static int height equals 50. Okay. Please, if you find yourself changing a constant in many places, do this for your own sanity. Otherwise, you're going to miss one. Okay. Okay. Still off the world. Come on, okay, let's go back to drawing 1. Okay, there it is. Oh, really not having enough screen is not ideal. So it goes. How big can I go? 45 maybe? Okay, fine. I could edit the TA render, but I'm not going to. Okay, let's see. So we should start it up higher at like maybe position 40. Okay, and then we're going to do minus. Let's do 3 hexagons again. Okay, great. All right, so we got 3. That's good. We still don't have quite enough space. All right, cool. What do we do next? We do 4 hexagons. So let's just call this thing again. We'll do mountain this time, so we can see what's going on. Where do you want to start it at? I don't know, like, yeah, maybe. Maybe I want to set up a variable here, which I'll call like x start equals 10. And now I'm going to say x start plus equals size. Something like that. Oh, we need another thing. Let's do hex size. While you guys debate, I will experiment. Okay, let's see what happens here. Okay. Oh. Hey, it ignored our mountain. Because we ignored the mountain somewhere. Oh, that should be T. Yeah. Okay. All right, okay. Getting closer. So we actually want 4 hexagons. Okay. Okay, getting better. So we need to, maybe we'll make a thing for y start too. So and y start equals 40. So our x was off, obviously. I'm not gonna mess with y start yet. Let's fix x first. Okay, how far, are we in the right position? Oh, maybe we're actually fine, right? We just need to, no. It should be over more. Yeah, let's scoot y over a little bit. So y start, I hope this is fun and not boring, by the way. I'm having fun. You're just watching me like cook, basically, I guess. Well, I didn't mean it in that cool Gen Z way. I meant literally just like concocting a thing. Okay. Nope, ran out of space. Okay, let's go a little smaller. I feel like we're having a screen real estate problem in general.
Oh, when it overflows, it crashes because you have index out of bounds.
Oh no, I did it again. Wrong stop button. Okay, we're getting closer.
That's why nothing gets split.
Okay, here's 3. Still not quite right. Okay, so tell me how you want to play around with this. Give me some suggestions. How should I change these?
X start should be another 2, like 2 times X.
Yeah, maybe like that. Okay, we're getting closer. And we're almost done with the world generation. Ooh, looking good. Something a little funny going on here, though. One moment. I think we just caught a bug in our earlier code, though. Look closely at our hexagons. Something weird going on here. Okay, let's fix that.
It's 3 times size minus 2.
Right. Okay, let's.
Yeah, it is, yeah, okay.
Hexagon. Okay, what did you think it was?
3 times size
3 times size
minus 2.
minus 2. Is the first length? Okay. All right, well, there you go. You thought about it harder than I did. Good. Okay.
Well, it works for 4, therefore we have the expression that also works for 4.
Right. Let's do a little test here. Let's make our hex size bigger, seeing if it fits. Okay. Does it look right? Yeah, that looks good. Okay. Cool. So a thing I forgot to do earlier was test out other hex sizes after we finish our hex function. Okay, good. Anyway, subtle bug that you had already pre-solved. Thank you. And let's keep going. And we're very close to done. Okay. Okay. Oh, getting close. What do I need to do? -1. Okay. It should fit beautifully. Okay, good. All right. Now we just do it again. Okay, what do I think the pattern's going to be? Well, it's going to be just as far over. And the y start, it should also be that same amount. Now we're going to do 5. Although now we're going to run out of space. So we're going to scoot the whole thing over, down a little bit. Let's do, I don't know, sand this time. Not totally sure it'll work, but I bet it will. Oh, I scooted it too much. It's looking good. Okay. It does look more like hay. I'll grant you that. 30. Okay, let's keep going. We're very, very close. It'll get more interesting, I think, when we can start doing more artistic stuff. Sand, flower, and what do I do? Grass, I guess I'll do last. Off the top of my head, those are the ones I remember. Okay, almost. Okay, we need to do what here? Yeah, minus equal these. Okay. And again, it is totally fine as you build your world generator for Project 5 that you experiment like this. This is what I've been trying to demo, basically, is that this is all fine. Okay, so we built the hex world. This one's always exact, some specific set of biomes. I want to make them a little more interesting. So let's change. Any questions about this so far, though, process-wise or whatever else? Yeah?
Would you write tests?
You can't really write, I mean, you could write tests, but I actually think in this case it'll waste your time. But you could write, like the thing you were thinking was, what are the invariants? Oh, it should actually be, 3 times size minus 2 or whatever. But once you know that, then like, what does the test even mean? Like, you've derived the formula. So I'd say for this, it's not worth writing tests. Let's do one more thing, which is I'm going to change the hex column thing. Instead of TE tile, I want it to be a random tile. And to do this, I'm going to generate this randomly at the time that I create the hexagon. So to do this, I am going to say, I'll use standard random dot or what do they call it? Uniform int? Yeah, okay. So I'm going to pick one of 5 random biomes. This is something that's just in the spec for the project. So this is like biome number. Okay, so this is the random biome number, and then I'll use a switch. So I'll say switch. I don't even know if you know what a switch is, but I'll demo it. So switch biome number, if it's 0, I'm going to say t tile, t equals null. Case 0, t null is going to be t equals, I'll just do them off the top of my head. Tile set dot mountain. Case 1, t equals tile set dot sand. Case 2, t equals tile set dot grass. Case 3, t equals tile set dot flower. Maybe. This is what I decided to do because I felt smart at the time. Array might be smarter. Just pick from an array. Tree. Okay. Yeah, this is not the right call because now I have to have a break here everywhere for reasons that I can't explain right now. And I need a default. T equals. It was a weird choice, but that's fine. Say again? I could. I don't know. It's explicit. This is what I decided to do, though. All right, and we'll put in T here. Let's see what happens. Why can't I do this? Oh, because I can't do this. I have to pass in nothing. Okay, and now we'll get a random world, hopefully. One more. All right. Okay, yeah, so we generated a random world. We can make different sizes. All right, so hopefully that process was interesting to see that, yeah, like messing around with it is fine when you're building code. Okay? One other little trick I'll show you, which is kind of cool, is there is also in the TE tile library, I'm going to throw this out there, something called color variant, where you can give a range of how much you want the R, G, and B values to vary. You give it a tile, and you give it a random object, which I'm not going to describe it all. But if you do that, and you run the world generator, oopsie, it's not called T. Oh, it is called T. Oh, T's first. So this means deviate as many as 30 different color values, and you'll see that the mountains are all slightly different colors, so you get a little more texture to your world. These ones didn't really vary as much. Yeah. Yeah, it looks more, yeah, all right. Okay, so that's just a little fun thing. Yeah, all right. Okay, last thing I want to do is show you the second part of the project, which is adding interactivity. I want to be able to walk around in the world. Okay, that's the last thing you're going to do like in a few weeks, which is I want to be able to, when I walk around, I'm going to do the following. I'm going to say int player x equals 25, int player y equals 25. Then I will do world player x player y equals tile set dot avatar. That's just like a little @ sign. Oops. And then I'm going to say while true. Actually, I will do this in here. While true, what will I do? I'm going to say if standard draw dot has next key typed, then character C equals standard draw dot next key typed. So that gets the thing that the person's pressing. And then I am going to do the following. I'm going to say, I'm going to be real lazy. If C is W, then what should I do? I'm going to go up. Y equals Y plus 1. Okay, if C equals A, player Y, that's why it was red. Okay, you could. Plus equals 1, I like that better, thank you. declare x minus equals 1. If c equals s, we'll go down. I could do a switch here, but I like to use a switch for the wrong thing today. C equals d. I just figured since you don't maybe never seen a switch, I wouldn't do it to you again. Okay, I think that's probably right. And then let's draw. Let's see. Then we'll do ter.renderFrame world. Okay, actually, I'll do that only when the player pushes a button. I think it'll reduce the chance that we just render the world over and over for no reason. And let's see what happens. So are we in the world? Oh, we're not there yet. Oh, no. Now we can walk around. So we can move, but there's a slight issue, right? Few issues. One, I can leave the world. And the other, yeah, it'll crash. The other is that I'm like leaving a trail of myself, which I don't really want. So any suggestions about how we can fix that issue of leaving a trail of yourself, yeah?
Also put the hexagons in the wild.
You could redraw the hexagons, which is, I think, the smarter plan, but the problem is we didn't actually keep the hexagons. We created them, drew them, and then threw them away. So we could refactor the design, which was, in my opinion, wrong. Because right now the world state exists only in the graphics, like the world thing. Yeah, or we could do the other thing, which is like save the tile value. So I'm going to create a t tile, like, yeah, previous tile. Yeah, player X, player Y. Okay, so what I'm going to do is have previous tile. And that's going to be, remember, like where, this is where I was standing. How about that? Where I was standing. Okay, that's where I was. And then what we'll do is, before we erase that, we're going to say world. Actually, before we do any of this, oops. Yeah, before I modify player X, player Y, when someone presses something, we'll do player X, player Y. So where I'm currently standing equals where I was standing, like whatever the object was. And then right here, we'll say where I was standing equals world player X, player Y, because like the position's moved. So get the new where I was standing, and then render. And this should look good. I think the way I wrote my code, you won't see me until I make my first move. But now when I walk around, it feels more like I'm in a world. And I can go visit the flowers, and I can go visit the mountains, and I can visit the trees, and I can walk out of the world. Okay. All right. That's more or less what you're going to do in Project 5. But your world generator is going to be more interesting. And you'll also have some logic so that you can interact with the world in some way. Yeah. It's the x, the integer x and the integer y. That's like where I am. So this might be like 30, 30, and then this is 30, 31, 30, 32. Yeah. And then the code I just ripped through super fast. This is basically just like the stuff where I was standing is maybe a better name for it. Yeah. Right. The stuff where I was standing. So when you leave, you put the mountain back, and then you keep going. Yeah. Yeah. Right. It would be very convenient when you walk around if you had to like replace the molecules behind you. Okay? All right. So that's basically what you're going to do in project. So I didn't really know how long this was going to take. I said maybe we would refactor. Let's think about parts of the code that are a little ugly, just while we're at it. Like, what are some, like, I guess, bad code smells, as they call them? Things that feel like, I don't know. Yeah.
Text size, like, there's only 5, and it's, like, a lot, which could be in a loop. And
Oh, this right here? Well, that's an argument to be made. Like, is this bad? I actually am okay with it. But you could write more generic logic if you wanted to be able to have customizable worlds. Sure. Yeah. What else? Yeah. I'm also not a big fan of the kind of weirdness that we have, like draw horizontal line in Lec 31. I don't know. I kind of feel like there should be like a separate library for drawing that's not this class, like a draw utilities. I don't know. That might be nice. And I think another thing is that like we didn't keep the hexagons. They were only temporary. So I think having some data structure, like it'll probably be that you'll have a data structure with rooms, and you should keep your rooms around, because you're gonna have to like make connections between them. And if you only have the if the only place the rooms exist after you create them is the world array, it may be harder to do things that are dynamic. Like imagine if I wanted to like delete hexagons out of the world. Like I use some item and this grass is supposed to disappear. Then it would be very hard to do because I'd have to like figure out where the hexagon borders are. But if I actually saved the hexagons in a data structure, I could fix it later. Okay. So, this works, but it's a little messy. Okay. So one thing I'll note when you're doing project 5, maybe take some time after you do an exercise like we just did with your partner. By the way, it's a partner project, where you're going to go, let's clean things up a little. It might help. And unit tests, not for the drawing, but for other things, can be nice as you're trying to do refactoring. Like, suppose you have some interesting logic that does, I don't know what, maybe write some unit tests to make it possible to refactor. Okay. Was that fun? I hope. A little experimental. All right. Last thing I want to talk about before we go is just a little bit more from our project. So in the previous lecture, we talked about complexity. We said complexity is something that makes the system hard to understand, hard to modify. And nothing you've done in this class, other than 4, the last part of 4 maybe fits this bill. 5, you really will feel it. And you're going to build 2 things. First is a world generator that instead of a hex world will be rooms and hallways and whatever else you want to do. And then an interactive stage that's going to be more than just walking around. So you can't walk through the walls, and hopefully you can do something cool, whatever it might be. In that world generation phase, should say, part B, we renamed it. Yeah, A is design doc, B is world gen, C is walk around. You're going to be given a number, and you're going to have to generate a world with rooms and hallways, and you can put stuff in them if you want. And then in part C, sorry, we just renamed these like literally minutes ago, so I hadn't updated everything. You'll add the ability to walk around, just like we saw. Okay, here is an example of actual 61B student code for this project, where someone is trying to handle moves. And you can see how it got out of hand because the programmer is being tactical, and that's fine again while you're playing around. But you can see that there's a lot of complexity here. Like, throw out something that's kind of obvious about it that's complex. Yeah? Yeah, I guess that's true. The if statement looks a little complicated, right? I mean, this bounds checking happens over and over. And each of the bounds checks is the same as all the others, but with slightly different math. Like, this is a debugging nightmare, right? Because you're going to forget one of these -1s. And then you're only going to be able to walk through a wall going down or something, right? It's not going to be fun to debug. Yeah, so there's plenty of things here that are a little funky. And you can see this person also used the let's replace the floor when we leave approach. Yeah. Saying just a little more from the Oosterhout book, there's 2 main sources of complexity. One is dependencies, which is when a piece of code, you can't just read it and understand it, basically, or you can't modify it. And obscurity is when important information is not obvious. And both of those things happen here. So try and look out and avoid these things. So I labeled some of these things, like there's some obscurity here, which is that I can't read this code and obviously know that this is west. I mean, maybe I can, maybe I can't. I tend to find that all this like repeat computation of west, north, and south is going to bite you in some way. Because again, you could have some mismatch. Like this -1 always matches this +1. I'd rather it be narrative, less obscure. There's a lot of variables that have to be manipulated in exactly a certain way. That's a little strange. And then there's also dependencies. There's this like repetitive code that I'm always having to do all these repeat steps in just the right way. I guess my last thing I want to show you is this dog. So when you're working on this project, you really want to avoid being this dog. We were this dog a little bit today, but when you're stuck.
Come on, let's go.
Yeah.
Come on. Come on. Come on. Come. That's a good boy. You did it.
Recording stopped.